Welcome to section 3.2. We're dealing with log functions today, and we're going to be graphing. Basically, the majority of this section will be without your calculator, so if you put that aside, you won't be tempted to use it. As we go through, we want to talk about different functions. In the first section, we looked at exponentials. Exponential functions are in the form of y equals a to the x. So that's the general form. We're looking today at its inverse, which is a log. And a log function we did in Algebra 2, but this is log base a of x. And you'll notice the base of the exponent is the same thing as the base of the log. That's super important as we go through because we're going to be using our exponential functions to write the logs. Let's look at the definition. Basically, here's what your book says. When x is greater than 0, a is greater than 0, and when a can't be 1. If the base is 1, then you're just dealing with a line, so we're not looking there. Then you have a function y equals log base a of x if and only if x equals a to the y. And basically, I'm going to show you, we're going to talk about rewriting logs and exponentials kind of as we go through on the back side, but we did a lot of rewriting from logs to exponentials in Algebra 2, so we want to bring that back. The first thing we're going to do is look at how to find an inverse, and then I'm going to use that idea kind of going through to answer the ones below. In order to find a log, here's what we're going to do. The inverse process says 1, switch x and y. And then the second thing is solve for y. And we did this in chapter 1, only just not with logs, but we did it with other functions as well. And so here's what I want to do is we look at this. My first step, switch x and y. So x equals the log base a of y. And now our goal is to get the y by itself. And so this is where the rewriting process comes in that we did in Algebra 2. And we'll notice that the base of the exponent is the same thing as the base of a log. And so we're going to start, and we did it in Algebra 2 kind of using the loop-de-loop method, and I'm going to go that way as well. If you always start with the base, then I go base goes across the equal sign and pushes the x up into an exponent. So a to the x crosses the equal sign again to say equals y. And so my inverse of this log is y equals a to the x. So one more time just to see that because we're going to be using it again. Start with the base of the log and loop-de-loop your way around. It goes across and pushes the x into an exponent and then comes back around and says it's equal to y. So going through, we're going to do a lot of rewriting today. It's going to help us kind of do things without our calculator. But again, to find an inverse, biggest thing to know, the inverse of a log is an exponential and vice versa. The inverse of an exponential is a log. And so keep that in mind. At least then when you get to a quiz, even if you're not sure how to do the loop-de-loop, you at least should be able to say, okay, it gave me a log, so the inverse has to be an exponential. So that's the start. Let's move around and we're going to do some graphing. Let me see if I can get this. All right, I'm going to start off, we're going to do two colors again. This 3 to the x again was from yesterday, so let's see if we can do this one more time. 3 to the 0 power, let's start off correctly, shall we? 3 to the 0 power is 1. 3 to the first power is 3. 3 squared is 9. 3 cubed is 27. 3 to the negative 1 is 1/3. 3 to the negative 2 is 1/9. And 3 to the negative third is 1/27. Okay, let's graph it. Again, 1/3, 1/9, 1/27. Don't forget to get close to the x-axis, but try not to touch because I have this asymptote that's here. So my domain for this was all reals. My range was from 0 to infinity, not including the 0. The only intercept I had was a y-intercept, and that occurred at 0, 1. The asymptote is the x-axis, which is the equation y equals 0. It is continuous. It is also increasing. It is 1 to 1, which means it passes the vertical line test and the horizontal line test. And so that is what we spent the majority of our time in the notes on yesterday, was graphing these exponentials. What we're going to do today is graph its inverse, which is a log. Now, what I'm going to have you do is instead cross off the f of x and make it a y. Let me switch colors. Okay, now if I cross it off and make this a y, what we're going to do so that we can use the same idea that we did above is rewrite this. We always start with the base, okay? 3 to the y and loop-de-loop around equals x. What this says for us is now we're going to plug in values for y and we're going to get out x values. So if I plug in, I'm going to plug in the same values for y that I plugged in for x above. And so I'm going to plug in for y -3, -2, -1, 0, 1, 2, and 3. And so basically what I'm going to do is just plug them in for the y. I'm going to get x values. So when I say 3 to the -3rd, we just did that 1/27, 1/9, 1/3, 1, 3, 9, and 27. And what happens this time, and you only basically plug in your things different to make the table. Now I plot my points the same way I did before. So at 1/27th, which is really close to the y-axis, I go down to -3. At 1/9, I go to -2. At 1/3, I go to -1. At 1, I have a y value of 0. At 3, I have a y value of 1. At 9, I have a y value of 2. And what you'll notice, that's all I can seem to graph, is I get a similar look, but there's special characteristics about that. The first thing you'll notice is it doesn't touch the y-axis this time. So now I have a horizontal asymptote at x equals 0. So it is now a horizontal. You'll notice the exponential was at y equals 0. The log is now at x equals 0. The domain, as you look, I no longer have any negative x values. So my domain is now from 0 to infinity, but I don't include the 0 because I had that asymptote. My range, I have -0 and positive, so my range is from -infinity to infinity. And you'll notice again, these are the opposite. These basically switch, and that's what happens with inverses. In my exponential, I had a y-intercept. In my log, I have an x-intercept, and that x-intercept occurs at the point 1, 0, and you'll notice the x and the y values switched. Is this continuous? Absolutely. We didn't need to pick up our pencil. Is it increasing? Yes. Is it 1 to 1? Yes. It will pass both the vertical and horizontal line test, therefore it's 1 to 1. One thing that you should remember, hopefully from inverses, is inverses can also be shown by a reflection over that y equals x line. And if you notice, this does, it reflects, it basically switches the x and the y values, and so that's what's happening here. As you look at this, it's a reflection over the y equals x line. Okay, you will have to graph logs and exponentials without your calculator, and the best way to do that is to rewrite it. 3 to the y power now equals x, and you plug in your y's instead of your x's. So keep that in mind. As we look at transformations, basically it's going to work the same way as it has with any other graph. And I'm going to switch my color again. If we look at this, and I want it to shift left 5 units, then I've got to tie it right in with the x. And so what I'm going to say is basically log base 3, if I'm shifting left, then I say x plus 5. And I'm going to stick that in parentheses so that I make sure that I tie it with the x value. In part B, if I want to shift it down 2, we always put that kind of at the back end. So log base 3 of x down 2 means a minus 2 at the end. If I want to reflect it over the y-axis, then I need to tie that in with the x value. So this is going to be the log base 3 of negative x, or the opposite of x. If I want to do a vertical stretch that was outside our function, so we'll say 7 times the log base 3 of x. Okay, again, we could do the other ones, but these are just a couple so that you can kind of get the idea that basically for every function, those rules apply. So flip the page, let's see if we can look at a few to actually evaluate a log without using our calculators. The definition for a log base a of x equals y, if and only if x equals a to the y power. And again, you're rewriting a to the y equals x. You're looping around. Log base 10, there are two logs which your calculators will do. A base 10, we don't write the base 10, we just say log of x. Okay, it's like the little 10 is implied, we just don't write it. Log base e is written natural log. Okay, so anytime you see either of those, your calculator can do those. Any other base, it's not as easy. Now I know the 84s can, but please again try and get away from that because you're not going to have your calculators for the majority of this chapter. Okay, our goal is to figure out what is the answer to this log, and we're going to do that by rewriting, and that's the easiest way to do it. Okay, and so we're going to rewrite this log. 2 to some power equals 64. Now, if you're not sure, let's talk about the fact that if you didn't have your calculator on a quiz, I know that 2 cubed is 8. Okay, so let's keep going. 2 to the 4th then, take 8 and times it by 2, you get 16. Not it. Okay, 2 to the 5th, multiply 16 times 2, you'll get 32. Not it. Okay, 2 to the 6th, if you multiply 32 times 2, you get 64. So my answer is the exponent, which is 6. Okay, so the answer to a log, maybe we should write that out. The answer to a log is the exponent. This is important, okay? If you know what you're looking for, it makes the problem a whole lot easier. So the answer to a log is an exponent. Let's do the same thing then. Let's rewrite this. 7 to what power is going to get you 1? Well, it doesn't really matter what the base is. Anything to the 0 power is always going to be 1. That's the only way really you're going to get 1 unless your base is 1. Okay, let's go to the next one. In C, 9 to what power is 3? All right, this one's a kind of a tough one because you're kind of looking at the idea that you go from a bigger number to a smaller number. And a lot of people start thinking the answer is negative, but please remember negative exponents take reciprocals. So let's do it this way. How would I get from 3 to an exponent to get 9? Well, 3 squared is 9. So if I go backwards, 9 to the 1/2 is 3. And remember, 1/2 is a square root. Okay, so if you're not sure, go at it the other way. 3 to what power gets you 9? It has to be basically the reciprocal of that to go backwards. Okay, let's go to the next one. D, 10 to what power is 1 over 100? Well, how do 10 and 100 relate? 100 is the same thing as 10 squared. Okay, and it went from a whole number to a fraction, which means my exponent has to be a negative, so my answer is -2. Okay, the last two, so all of those are no calculator based. The last two require your calculator. And all I want you to do is make sure you know where your log button is and where your natural log button is. So in your calculators, find your log button and take log of 25. And let's round 1 decimal place. I think it should be about 1.4. And I'm going to change this instead of equals to an approximately. And that's because 10 to about the 1.4 gets me close to 25. And remember, this is a base 10. Natural log is a base e. So we're saying e to some power is going to get me about 32. And I'm using approximately because we have decimals. And if you stick this in your calculator, let's go 2 decimal places in this case, you should get, I believe it's 3.47. And so we're saying e to about the 3.47 should get me close to 32. And so this is kind of the idea going through. If it's a base 10 or a base e, you can use your calculators. Anything else you would want to start rewriting to start looking at exponents. Okay, we have one more chunk of information. There's a few log properties, and then we'll be all set. I'm actually going to, get rid of this. Again, please look at your schedule. Let's take a look. Log base a of 1, we just went through that one that was like letter B above, is 0 because anything to the 0 power is 1. The same thing works with logs because e to the 0 power also gets you 1. If I have a base of a to what power gets me a again? The answer is 1 because a to the first is a. Same thing, this is a base of e, so e to the first gets you e. This third and fourth property are going to be huge for us. We are going to use these two probably the most. Here's the exciting part about 3. If the base of the log is the same as the base of the exponent, the log and the base will cancel. You're left with just the x. So it works both ways, whether you start with a log or you start with the exponential. The base of the exponential is the same thing as the base of this log. They cancel, you're left with the x. Natural log works the same thing, and if you need to throw that base e in there, you can. Base is the same as the base of the log, so my answer is x. Base is the same as the base of the log, so my answer is again x. Okay. Number 4, if you remember from last section, this is the one-to-one property. It works not only with exponents but also with logs. So if the base of the log are the same, then x would equal y. You can cancel those out, the logs and the base. So this is a base e, this is a base e. Again, you can cancel it out and x equals y. So I just want to practice a couple a second. G, if the base is the same as what's there, your answer is 1 because the square root of 8 to the first power would give you the square root of 8. In H, the base of the exponent is the same thing as the base of the log. They cancel, you get 22. I'm actually going to move straight down. The base of the exponential is the same as the base of the log. Those cancel, you get 5. I is the one that's the most tricky. I have a base e. I'm going to rewrite this a second. E to what power is 1 over e cubed? Because I think it's easier to look at it this way. Well, e, if it's e cubed is in the denominator, we went from a whole number to a fraction. That means our exponent has to be negative because this is the same thing as e to the negative third power. So I'm looking at this, the natural log base e of e to the negative third. I can now see that I cancel it out and get negative 3. Okay, these properties we're going to continue to use as we go forward, so kind of keep them in mind. But please know you can always rewrite things if you would like to be able to see that. So thanks for watching section 3.2. Please again circle, star whatever questions you had, and we will go through those in class.